In production GenAI systems, most model queries are repeats of something the system has already seen. The model just doesn't know it. 1,000 customers ask about the same refund policy in 1,000 different ways. Yet the model does the same work, over and over again, each time wasting compute, increasing latency, and consuming valuable GPU capacity. The obvious fix is a cache. Store an answer once, reuse it. But for language, caching has always carried a catch. Take an exact match cache. It only reuses an answer when the new request is identical to an old one, right down to the character. But people rarely ask the same question the same way twice, so it almost never finds a match, safe but close to useless. A semantic cache tries to solve that by matching requests that look similar. The problem is that similar is not the same as equivalent. Two queries can appear nearly identical while carrying fundamentally different meanings, leading to completely different answers. So a semantic cache starts serving wrong answers confidently to real customers. Useful, but unsafe. And it carries a second cost, one that is easy to miss. To judge how similar two requests are, a semantic cache runs a transformer model on every single lookup. That model needs a GPU of its own. So the cache you added to cut GPU spend now demands more of it, sitting right beside the GPU already running your LLM. You pay for the same scarce hardware twice, and the savings you came for shrink before you ever see them. For years, this was the trade, safety or savings, never both. Bud Cache is built to give you both. It is built using resource-aware attention. Most AI models are built for expensive GPUs, then shrunk to fit commodity processors, which leaves them slow. Resource-aware attention is built for everyday CPUs from the ground up, so it delivers GPU-class performance with no GPU at all. Bud Cache sits in front of your model. Instead of asking whether two requests look alike, it asks whether they would get the same answer. To decide, it reads the details that actually change an answer. The entities, the numbers, the constraints, any negation, and the intent behind the question. It reuses an answer only when both requests match on all of these. Only then are they genuinely asking the same thing. That distinction is the whole product. A missed reuse costs you one model call. A wrong reuse costs you trust. So Bud Cache is biased towards caution by design. Here's what that looks like in numbers. On a sealed benchmark, Bud Cache reaches 92% decision accuracy at a wrong answer rate of 1.5%. It still reuses answers across roughly 4 and 5 genuine repeats, so the savings are real rather than theoretical. And that wrong answer rate is not a hope. It is held under a target you set with a mathematical guarantee. It does all of this on ordinary CPUs. A cached answer returns in about 0.2 of a millisecond on a single core with no GPU. That makes a hit thousands of times faster than calling the model, and it cuts your GPU demand without adding any of its own. It is also ready for production from day one. Strict isolation between tenants, so one customer's answers can never reach another. Erasure that meets compliance requirements and survives a backup restore. Automatic freshness rules, so anything time-sensitive is never reused across a day boundary. It tunes itself to each workload and gives you a single dial for how cautious you want it to be. The result is simple: lower inference cost, faster answers, and a safety profile you can stand behind. Reuse what your model has already answered, safely, instantly, on the hardware you already own.